Okay, so this is going to be a review of possibly the hardest problem that's going to be on the test. The problems might not be exactly like this, but some of the concepts would be the same. So that involves what I call, and we call in class, the third type of projectile motion problem, where you're going to be launching the object off some cliff, and it will strike the ground below. So there's quite a few things that we could solve for here. I worked out some of the math pretty quick here after class, and I'm going to skip some steps that you should go back and make sure that you know how to do. So we're going to assume that the initial velocity of the ball being thrown is 25 meters per second at 65 degrees. When we do our components, which is always the first step, you should get 11 meters per second, and then VIY would be 23 meters per second. If we take a look at which one's larger, it's VIY, and it makes sense because our object's going to be launched above 45 degrees, which means majority of it will be in the Y direction. Okay, so that's why that one should be bigger. It's a good check. Make sure that you know how to find the VIX and VIY. The next step that we always find is time. And for these problems, it'd be very nice if they give you the height of the cliff. There's two ways that we could go about it, or two ways that the problems could be set up. One would be if they just give you the time, and another would be if they give you the height of the cliff. So the height of the cliff, we'll say for this problem, is 50 meters. Remember, we call that our starting point. The object will go below it, so we call it negative, right? And then to find time, you're going to use a quadratic. Okay? And the equation that we use for that is y equals VIYT plus 1/2 GT squared. It will end up looking like this to try to cut through some steps and to make this a little shorter. The initial velocity in the Y direction would be 23. This is negative 50, and this is negative 9.81. Okay. So when I take my Y to the other side, it becomes positive 50. I'm going to ignore units for now. The velocity and the initial velocity in the Y direction, and then I just put into the calculator 4.90. Okay, if you have 4.91 or negative 4.91, that's fine, but once again, for time's sake, we're just trying to speed along. You're going to get two values in the quadratic. The first one is negative 1.6 seconds, and then the second one is 6.3 seconds. For some reason right now I'm thinking that's higher. If you were to check this, hopefully you get the same answer. I used an online calculator for quadratic formulas. Now we know that you cannot have a negative time, so that's why we have to pick this one. So now we have everything we pretty much need. We have the initial velocities, we have the Y, and we have time. And so our steps now, depending on what we're looking for, is find everything else. Okay. One thing that you might have to find is the maximum height. So the maximum height is actually right up here. And we know some things about that. The one thing that we know is that the velocity in the Y direction is equal to 0. So the way I kind of act like the problem is done is a ball is thrown straight up with VIY. Goes up, comes back down. We are trying to find this. So I'm going to call the final velocity in the Y direction 0 because the ball stops momentarily before it comes back down. So we're going to solve for that. I use the second equation with the squares in it. So VFY squared equals VIY squared plus 2GY. And I know all of those things. I know this is 0, and I'm going to solve for y. So we put negative in there, 23 meters per second squared divided by 2 times negative 9.81. I didn't actually do this calculation, so I'll do it now. When we square the 23, remember that initial 23 up is in the positive direction. The negative comes from subtracting it to the other side. So we don't square the negative. Okay, so we're going to have a negative divided by negative, and we'll get a positive. So y is equal to 27 meters. It's actually positive. So therefore, max height is equal to 50 plus 27 meters would be 77 meters. So it's 77 total meters from the max height, or from the ground to the very maximum height. Some people stop the problem after this. You should keep going. Make sure you do the addition. And then lastly, one of the things they tend to ask for in these types of problems are what is the final velocity here in the y, or in the, sorry, just what's the final velocity? And you need two things. You need to find the components. Right? So if we were going to make a triangle out of that, to find the components, this would be VFY. It could also be here. And then over would be VFX. And then we get this triangle that looks like this. To make it a little bit larger so you can see it. So the step now is to find the components. We know that VFX is the same as VIX, so it's still going to be 11. We need that. And then we could find VFY by using what we call in class the first equation, first kinematic equation. So VFY is 23 VIY plus negative 9.81 times time. And I hope this is fitting on the screen. So when we solve for that, oh, and the time, we can put time in. 6.3 seconds. So 23 plus negative 9.81 times 6.3, we get a VFY of negative 38.8, so negative 39 meters per second. That's really fast, okay? 80 miles per hour, 80 to 90 miles per hour. Okay. One assumption we make is no air, so that is possible. So in class, when we did vector addition, to find the magnitude of the final velocity, we used the Pythagorean theorem. If you put these values in, you should get a final velocity of 41 meters per second. Some students forget and they stop here. We also have to find the angle, which is going to be tan to -1, right? VFY divided by VFX. So when I do that, we should get -74 degrees. And that's okay, you can leave that as a negative, I'm okay with that, right? That's going to be this angle right here. We could find what it would be in the positive, but that's okay for negative. So my final answers, if I had to write them over here, our time would be 6.3 seconds. Okay, my max height, Y max would be 77 meters. If you don't put the positive in there, that's fine. And then my final velocity, VF, would be 41 meters per second, 74 degrees negative. And that's it. That's the final answer. It is a pretty involved problem. You have to be very careful, pay attention to some things, watch your signs, but it's doable. So there's different ways that we could look at this problem too. Like, let's imagine you have a plane that's flying upwards and then they release a bomb. So that bomb would actually do this. It's the same type of problem, it just sounds a little bit different.